Okay, you guys, let's take a look at momentum number 4. These are two questions that are both two-dimensional questions, two-dimensional collision questions. They have a different focus, though, a little bit. I would say this one is definitely the more challenging of the two. This one's not too bad. All right, so you're given automobiles of equal mass. We've got one traveling. All right, so here's the momentum of number 1 traveling toward the east, the other's traveling toward the north. Okay, and then they collide and they stick and they travel at an angle of 62 degrees or whatever it tells you guys have. All right, determine the initial speed v2I of the northward moving vehicle. Okay, so what you really want to look at here is solving this in both directions and using a system of equations, because you're not going to have enough information to solve any one given direction. Okay, so in the x direction, can we see that? Not well. Let me move this over a little bit. There we go. So in the x direction, let's consider that you have your initial your momentum of car number 1. And then for your final momentum, you're going to have, obviously both the masses put together, and the final velocity is going to be the final velocity times the cosine of 62, or whatever your angle is supposed to be. Okay, so now they don't give you a mass, but they do definitely tell you that they are equal. So, you can just use the numbers 1 and 2. That makes life a lot simpler. All right, and so you can put this in terms of, let's see, m1v1, right? So you can put these in terms of initial and final velocity. And then this will obviously just become numbers 1 and 2, which makes life a lot simpler. And then you can do the same basic idea in the y direction. All right, do we have room? Hopefully we can see that. All right, so you have the initial momentum of car number 2 traveling north this way. All right, and then at the end, you're going to again have both of them together, just using simple, 1 and 2 for mass here, and then final velocity, sine of 62. That's going to give you a system with 2 missing variables, and you should be able to solve from there. So that shouldn't be too tough. Okay, the trickier of the questions is right here, this last one. So let's see if I can't make this reasonable for you. Okay, so they tell you that one mass is greater than the other. So in this case, it seems to be the mass of blue, and mine is 25% greater. So the mass of blue would be 1.25, and the mass of the green, I would just make it 1. That makes life a lot simpler. Okay, before colliding, they approach each other with momentum of equal magnitude in opposite direction. The cool part there is that the overall momentum has to be 0. And that's going to be a really handy little trick for us for this question. So definitely something that we want to work with. Okay, so what you are given here, you can see that you've got, well, let's say this one is the blue one, and let's say this one is the green one. And so the blue one goes this way, and the green one goes that way afterward, and you can see you have your angle with no problem. All right, so your initial momentum and your final momentum is 0. So at first, what you could do, since they do give you an initial speed on the green puck. In my case, it's 13 meters per second. What that allows you to do is to say, okay, well, my overall momentum is 0. That's going to be the momentum of the blue. Let's see, we'll do initial momentum. Or, yeah, we can do both in the end. All right. So we know the initial we know the initial velocity of the green. We can solve for the initial velocity of the blue. We can solve for that because we know that. All right, the next thing that I would do, it tells you about the kinetic energy being half. So if you've got your initial velocities, I would find your initial kinetic energy. Once you find your initial kinetic energy, then you're going to, of course, cut it in half, or whatever percent that you're given, right? That's going to be your final kinetic energy. This will be in terms of m, and that's no big deal at all. All right, because as you can probably guess, the m's will drop out in the end, so don't let that throw you for a loop. Okay, then what I would do is I would use the idea of, again, conservation of momentum, but now let's focus on the final momentum. Your final momentum has got to be 0. All right, now, when you set up this relationship and you expand it out, you're going to be missing the final velocity of the blue, you're going to be missing the final velocity of the green. When you expand this out, you will also be missing the final velocity of the blue and the final velocity of the green. And of course, then you can make substitutions, and that will allow you to find what it is that you need. So hopefully that makes sense. I know it's actually, this one is deceiving because it looks like you really need to use those angles, but the truth is you're not going to even need to do that. So, yay, actually a little bit simpler than we thought it was. All right, hopefully that helps.